Good afternoon, and thanks for allowing us to give a SEE4GEO presentation at the GeoEnergy conference. NORCE by Walter Wheeler and I, Midttømme, will give the presentation on behalf of the SEE4GEO project team. SEE4GEO, with the long title Seismoelectric Effects for Geothermal Resource Assessment and Monitoring, is a Geothermica 2 project with a total budget of 1.5 million euro. The project is led by Lawrence Livermore National Laboratory in US, and we have another US partner, University of Hawaii. There are 3 French partners, 2 industry partners, TLS Geothermics and India, and in addition the University of Po. From Norway, Monvido, previous Octio Environmental Monitoring, and NORCE is the partners. The project is a 3-year project, started in February this year, and as with all projects involving US partner, we have had struggling with the consortium agreement, and the contract and the agreements are not signed yet. Access to groundwater is crucial for open loop geothermal system, and the motivation for SEE4GEO is to be able to identify pre-existing and newly activated water field fracture networks on reservoir scale for image and assess geothermal resources and targets, and information on and monitor stimulation success and risk mitigation. Status regarding mapping water field fracture is that seismic imaging techniques fail to resolve fluid phase properties, and electromagnetic approach have limitation due to low resolution due to rock structure. In this project, we plan to combine these 2 geophysical techniques and use the seismoelectric effects with short name called SEE. The link between seismic and electromagnetic is illustrated in the figure. A seismic source triggers a seismic waves which propagates in a porous medium, which will induce charges between grain and surfaces and pores, and which will generate an electric dipole, and electric dipoles triggers an electric magnetic field. The objective is a low-cost deployment technique for imaging and monitoring of geothermal resources, and leverage in-house new software modeling for seismic electric effects. The approach is fully integrated by creating a SEE numerical package to be used for improved subsurface tomography, supported and validated by laboratory experiments and field surveys. The outcome of the project is a seismoelectric effect in hand technology for the geothermal industry will be able to progress from a TRL 1 to TRL 3. So this is a basic research project with high risk and lots of uncertainties. I will present the project activities, and are starting with numerical modeling. The aim is to develop software for subsurface imaging and characterization. This VP includes both forward and inverse modeling. 2 codes have been developed by the partners to model SEE signals. They are both using PRIDE formulation published in 1994. Lawrence Livermore have developed SPECFEM SEE, it's a time domain code, and the French partners have developed Houdini, it's a frequency domain code. I will show an example from previous SEE modeling performed by Lawrence Livermore in a carbon storage project. The case is shown to the left. It is a cross-well monitoring setup in a homogeneous porous medium with a seismic source located in well A and a series of co-located geophones and electrodes in well B. Following the trigger of a seismic source at depth with a frequency of 200 Hz, we display the model wavefront at different times of the seismic field and the triggered co-seismic electric field, which propagates at the same speeds. The triggered co-seismic electric field is due to local fluid flow generated by the seismic wave. In the figure to the right, vertical seismic displacement and electrical field co-seismic electrical signal in baseline case with brine in both wells are shown in the top figure. We see the P wave and the geophones at the corresponding co-seismic electrical signal. There is in addition a signal quasi-instantaneous electric signal generated when the seismic source occurs. This is marked in blue and number 2. In the bottom figure shows the same case with CO2 in well B. Here we record an additional electric waveform marked with green and number 3. This is a quasi-instantaneous seismo-to-electric conversion at material discontinuity at the interface between the brine and the CO2. The laboratory experiment is the second scientific work package. This activity will build upon previous activities at University of Po. They have designed lab setup for hybrid seismic and EM experiments. In SEE4GEO, the influence of physical parameters like temperature, salinity, and permeability on the seismic-electric effects signal will be tested. These data will help validating the numerical methods and optimize the design for the field survey. The last activity is field experiment. Walter will present the plans for the Norwegian field survey, but before that I will briefly mention that the French company TLS are planning field tests in crystalline rocks in Seoul license field in Rhône Alps region. Before Walter continues, I will acknowledge the Geothermica program and the funding agencies of SEE4GEO, US Department of Energy, French Environment and Energy Management Agency, and Forskningsrådet. Thank you.